In problem 45, two objects with masses m1 equals 10 kilograms and m2 equals 5 kilograms are connected by a light string that passes over a frictionless pulley, as in figure P4.3. If when the system starts from rest, m2 falls 1 meter in 1.2 seconds, determine the coefficient of kinetic friction between m1 and the table. So first we should find the acceleration of the system. So you plug in your known values to this kinematic equation. The first term will cancel because our initial velocity is 0, and then a will end up being 1.3 meters per second squared. Next, we should draw a free body diagram for each mass. So for the 10 kilogram mass, we have the force of gravity pulling down and the normal force pushing up, and then we have the tension pulling to the right. And then for our 5 kilogram mass, we have the force of gravity pulling down and the tension pulling up. So first we should use the sum of all forces equals mass times acceleration in the y direction to find our tension. So that would be our mass times the gravitational force minus the tension equals the mass times acceleration, and we're using our 5 kilogram mass for this one. So 5 times 9.8 minus the tension equals 5 times 1.3 meters per second squared, and our tension would end up being 42.1 newtons. Now we're going to use the sum of all forces equals the larger mass times acceleration to find our mu value. So we're going to plug in the tension into this because the tension is the same for both, and then subtract the friction and make that equal to the larger mass times acceleration. So our tension is 42.1, and then we're going to subtract the friction, which is mu times 98 newtons, because 98 newtons is the normal force, and to find the normal force, in this case it would just equal the same as the smaller mass times the force of gravity, and that would equal 98 newtons. So we plug that in and make that equal to 10 kilograms times 1.38 meters per second squared, and mu would end up equaling to 0.28